thanks very much for the invitation to be here. This is my first visit to the Kyrgyz Republic, and the hospitality has been wonderful. I'm really enjoying it. I'm Jim Cowie. I'm the chief scientist at Dyne. Dyne is a company that does internet performance. We fundamentally do measurement of the internet, how it behaves, and how it's developing, so that we can help our customers move traffic where it needs to go more efficiently than it has been before. I think that this was an excellent introduction about the way that the internet comes together. Fundamentally, the internet is based on bilateral voluntary cooperation. So there are more than 48,000 autonomous systems, independent organizations that have agreed to put their networks together to build the internet to what it is today. And they're routing more than 500,000 independent networks through this mesh of voluntary relationships. But as much as we all like the internet to grow and to expand as quickly as it can, obviously it's subject to some real-world constraints. And those constraints can be geographic, they can be political, they can be economic. Occasionally they are technical. That's actually the rarest case, I think. Most of the constraints to growth are geographic, political, and economic. So what I wanted to run through today was to take a look at the world, but more specifically at this region, to give a little bit of an overview in this segment about how this region connects to the internet and how it could connect to the internet. Because as diversity and connectivity increase, the reliability and the performance and the price all come into a better place. So this is our measurement infrastructure that we built at actually my previous company, Renesys, which is now part of Dyne. We do a collection of information about the way that traffic is being routed, as well as the performance of individual paths on the internet, using measurement points that we've built around the world, including many in this region, including one measurement point here in Bishkek. So Central Asia is a very interesting place to study the internet, because everything here is landlocked, and in fact because it's landlocked by neighbors who are themselves landlocked. It becomes very challenging to get enough different kinds of connectivity into these countries to make things really work well. So here we are. We want to increase diversity. We want to reduce latency. We want to improve reliability. And most of all, we want to reduce cost. It seems to be the most important single factor in really growing the internet. So I started by going to the Alexa list of important content sites. These are some of the top sites that are used by Kyrgyz citizens. And what's interesting is that from the start on the side you can see that many of these, I actually measured them from here in Bishkek. So where are these sites actually located? The top, of course, Google and YouTube. I found at the moment I tested at any rate that they were being served from Russia, either from Voronezh or perhaps a little farther from Moscow. So 50 to 70 milliseconds for the primary largest supply of content that's being consumed by Kyrgyz citizens. But then lcat.kg, number 3 on the list, is right here, which is fantastic. That's what we hope to see, that local content that's in great demand will be hosted locally, so that nobody has to pay for that traffic to be carried, requests out of the country, service into the country. We can roll right through the list. You mentioned earlier that there's maybe 200,000 Facebook users now. It's a very significant population. This is a difficult placement because there are caches for content from Facebook that are closer, but the primary website is on the east coast of the United States, so it's hundreds of milliseconds away. ts.kg is another site that's hosted here. If we expand to the top 30, it's really impressive to see how much of this is actually hosted here in Bishkek. This is all under 5 milliseconds from this room. And this is very unusual, actually, for a relatively small country to host that much content locally. It's very impressive. I work a lot with countries in the Middle East who consume almost all of their content from Europe or from the United States. They don't see their own flag on this list very often. So quite impressive to me, really. So all of that demand is what drives the internet. It's why we build the internet. We need something to carry that traffic, the part that's not hosted here, into and out of the country. So today I'll focus primarily on the international picture. So from that list you can see there's still a need to reach Russia, to reach the United States, a little bit to reach China, Alibaba. So let's figure out how traffic flows right now. So each one of these arrows represents a supply of transit. It's somebody selling transit capacity to somebody else. And you can see that the majority of it flows in through Kazakhstan, as you would expect from Russia. And from there comes out to the various republics here. But if you look at the bottom, I have a pointer. Here you'll see that there are other paths emerging in the southern part of Central Asia. So transit from Iran, transit from Pakistan, both of which are starting to increase the diversity of what's available, and that will filter through to this region as well. Then you ask, how can it change? So we think about watersheds, and I forget the Russian word for watershed, but when rain falls, it runs to some ocean. So which ocean will it run to? Internet transit is a bit like that. There are natural, because of the constraints of infrastructure, there are natural ways that traffic can flow according to the map. So obviously the Russian watershed is very, very important in this region. All the traffic here headed through Kazakhstan will go to Moscow and continue to international markets through the large internet exchange points at London or Stockholm, maybe Frankfurt. If you're in Afghanistan at the moment, at least in the Herat region, you may use your mobile phone and find that the data goes through Iran on its way through the Caucasus and even on a great circle route through Ukraine, which is quite amazing. But it all flows. The second watershed, we can think of this as the first alternative, Russia obviously the primary. The first alternative would be what we would call Balkan. Previously we might have called this Turkish transit or Istanbul transit, but now it's starting to diversify a little bit because there are cable systems underneath the Black Sea. There is Balkan connectivity that goes directly from Georgia to Bulgaria without making a stop in Turkey. But broadly speaking, we can think of this as the Turkish route. And Turkey drains a lot of the traffic from this region and from south of this region to take it to European markets. A second alternative is the classic one, submarine connectivity. These are the major undersea fiber optic cables that are bringing traffic today from Iran and Pakistan and from India and from the east, taking it through the Suez Canal in Egypt, which is a natural constraint, bringing it to European markets. We give an honorable mention to alternative 3, which is Chinese transit, which is not really used in this market right now, at least not in any significant way. It is there as a possibility, but China has its own challenges in terms of the extremely long delays that it takes for Chinese traffic to get to world markets. So if we buy transit here from a Chinese provider, we're just adding to that. Still, if we're looking for a diversity play, if we're looking for an additional source of transit, this would be a reasonable extra alternative. So we put this all together, we have this map that looks like a military invasion. So we wipe this away. Let us simplify this. If we simplify, maybe there's 4 cities that are very, very important for this region, for Central Asia. So Beijing, to some extent. Significantly, of course, Moscow. Istanbul, and Dubai, or perhaps Muscat. All of these are sort of the important ones. The hinge point is in Baku, or perhaps in Tehran. They're, for this purpose, very close together in the network, as the place where all 3 of these, the 3 Western alternatives at least, can be reached from. So to take advantage of that for Central Asia, obviously we can't do this today. There's something missing. Something needs to be built. There's 3 things perhaps. One, we need to borrow the Iranian terrestrial network. They have a very well-built network that can be used. We've already had conversations with some of the service providers there who, as soon as the political situation is improved, are very willing to be an international transit provider and an important hub for this region. Failing that, we need a route across the Caspian Sea. Or perhaps we need to figure out how to bring internet transit through Afghanistan and to reach Pakistan, and from there the sea. So we work through these. The Iran terrestrial net is up. It's ready for business, as they say. It's just politically a little difficult for some of us. Crossing the Caspian, we already have the TASIM project, which is very exciting. TASIM, I think, is most interesting, of course, for the Caspian Sea crossing, which is also the most difficult part. I don't know when to predict this. We were talking about this at dinner last night a little bit. I was being polite when I say there are only a few formalities before they can build this cable. It is the last difficult part. If we wanted to do this without the Caspian Sea cable, well, there are other alternatives. We have bank-supported projects to build international railways. Today, when you build railways, you lay fiber beside the rail bed. And so this map from Janozen down to Gorgan represents a new rail corridor which could support international internet connectivity. It's just another piece in the puzzle if we were going to try to go around the southern coast of the Caspian Sea instead of cutting across on a future cable. And this is perhaps an interesting one that I just learned about recently. This is the CASA 1000 project, again, supported by World Bank. And the point here was to couple together the electrical grids of the regional neighboring partners to bring hydroelectric power from when the snow melts here to markets in the south, and to improve the power grid stability of Afghanistan, and to provide power to Pakistan. When you read the engineering documents for this project, you realize that there are 24 strands of single-mode fiber specified, of which the project requires about 100 megabits of internet or of IP transit for its own monitoring purposes. The rest of it, and that's an enormous amount of fiber, should be available for sale. There are many places in the world where electrical grid interconnects have created new opportunities for internet to overlay on top of this new infrastructure. So if this could come together suddenly, it's very far south, very, very far south, but if this project were to come together, suddenly we could wake up tomorrow and find that Bishkek were 40 milliseconds or less from the ocean. This would be a new start. So I'll stop here because we're going to return to this later this afternoon in a panel on internet measurement. And we'll talk about specific numbers and specific measurements and specific metrics that we can look at for this region. But today, this is the message. We're looking to work around the constraints. We're trying to figure out surprising ways to tie networks together. And the good news is we don't have to figure it out. The market will figure this out. But it always helps to have people from the government, people who understand the policy, people who understand the funding, to be able to step in and support possibilities when those possibilities emerge. So I thank you for that, and we'll talk about this afternoon.